Yeah, it's themed on creative AI. So we're looking at how artists are using and thinking about the latest machine learning and artificial intelligence techniques. And yeah, just to give you some context, so this field exploded in terms of interest from practitioners, media, and the ordinary. We don't have the slides. But yeah, so this field exploded around 3.5 years ago when Deep Dream came out of Google. And it worked by taking normal images and kind of emphasizing the features to come out with kind of really crazy creatures and pagodas and other shapes. Like here you can see in the work of Memo Akten or in this work by Mike Tyker. Then there was an obsession with style transfer, particularly from the technical community. And you could change your beautiful view of Tübingen into something in the Impressionist or Expressionist style. And you could also do the same with Mona Lisa. And then finally with your own photographs, if you use this Prisma app, which was super popular about 2 years ago. And then the attention has moved to the GANs, which I think Mario might talk about a little bit more. But yeah, they have started creating some shapes which are a bit more realistic, but sometimes kind of the limbs or the eyes might be in odd places. And I think the attention of the community was kind of still stuck with this technology. And recently there's been a paper on the Big GAN, which produces more realistic results. And this came out just at the beginning of October. So personally, as a curator in this field, I'd be very curious to see how artists start adapting and working with this technology. And yeah, at this point, we're going to start with our panel presentations. And first of all, we will have Mario Klingemann, who is a German artist and Google Arts and Culture resident, also does his Wikipedia page say. And yeah, I consider him certainly as one of the pioneering artists working with all these latest AI techniques. So whenever one of these technical papers comes out, you will have Mario, who is experimenting with these techniques and applying them to the human form. And he has exhibited at a variety of institutions, including Ars Electronica, Museum of Modern Art New York, the Photographers Gallery, and the British Library. So, welcome, Mario.
Give me a second to switch. It's probably on there because it's on the other screen, full screen. Can you see that? I made exactly that mistake. That's the thing. So I got it. It was this one. Okay, perfect. Yeah, because whilst I'm kind of always working with technology, I hate having to present from not my own machine, and especially from a Mac. So if anything goes wrong, I blame technology. Well, yes, so as Luba already said, I've been trying to create interesting images using machines since kind of a very, very long time, I guess like 20 years. But since about 3.5 years, since Deep Dream came up, I pretty much exclusively focused on using neural networks, or let's call it artificial intelligence, in my process. And I will show you a little bit about how this goes. So, as you might know, we all have been living in Walter Benjamin's age of mechanical reproduction for the past 80 years. But it's kind of, yes, and now I don't have the, here we go. But now we might enter a new age, which is the age of artificial production, because machines are more and more capable of producing things that we might kind of consider to look creative, to look interesting, well, by themselves, or at least in the hands of artists. And then the question comes up, like, how much are artists still putting into this, or how much is coming from the machine? So yes, I've been, oh God, what is this? Lovely. Okay, so I try to make it with a... So yeah, I've been trying to kind of experiment with all these different methods for quite a while, and all the images that I show you are coming out of the machine. I don't use Photoshop or any other tool. So what I do, I build these systems, I train models, and then I set them up in a way that they can continue to give me, like, produce infinite amounts of these images, and in the end I sit back and have to curate what the machine gives me. And as you see, some of these are very surrealistic, I would call them. The interesting part is that because I'm training them on natural images, they borrow certain features from the real world, I think, which is what makes them so interesting. Or because they are in the middle between something illustrative and something abstract. And well, you think you discover something in it, but then it doesn't make sense. It's kind of in a weird context. And that is exactly where I find it to be interesting. I've experimenting with the human form, and for example, this, well, I was happily surprised that I just won kind of the Lumen Award, and which I actually didn't expect, because, I mean, yes, it's interesting, but, well, somehow these types of images are seeming to be quite interesting for all of us right now. And, well, I mean, in their... well, whatever, like the reason they chose it, they also, of course, mentioned something like, oh, yes, he's experimenting with textures, and it has a very kind of like a reminiscence of Francis Bacon. And yeah, that's kind of the problem right now, because a lot of the feedback I'm getting is, yes, oh yeah, this reminds me of Francis Bacon, or some other artist, because depending on what I'm doing, it kind of like, everything reminds us of something else. And yeah, I mean, oh yeah, especially that last one, that hurts a little bit. But, well, the point is, what we're dealing with here is what I call the Francis Bacon effect. And it's actually that our brains, like, the problem is not that I'm creating something that you might think looked like Francis Bacon, but we are very lazy. Our brains are kind of very lazy, and they are, or you could say they are very effective in kind of filing information. And if you look at something that has a face on it, which is kind of weirdly distorted, then, well, you do this kind of nearest neighbor search, and you think, okay, it's art, it's distorted faces, so who do I know? Oh yeah, Francis Bacon. And that's kind of like, your brain does this nearest neighbor search. I mean, there's other types of art where where it's getting a bit harder, because, I mean, people are making portraits and these things for a long time. But yeah, Francis Bacon managed to create this gravity field, which is very kind of strong, because it was very unique at that time. And so the funny thing is, as all of you, I know Francis Bacon, and I know his work, but I was never really kind of digging into his way of thinking. But now that I always got these references, actually I started a journalist sent me this video where he talks about his process and his work. And that was, I found, extremely fascinating. And then I got me this book with his interviews and read more, and I got even more fascinated. And I found these quotes which totally kind of, I found related to me. So I read it to you anyway. I don't really know how these particular forms come about. I look at them probably from an aesthetic point of view. I know what I want to do, but I don't know how to do it. And this is pretty much like nails it how I work. So I kind of know what images I want to get out, but in the end, my imagination and is not big enough to kind of actually, or go there and create the artifacts and all these things kind of pixel by pixel. So what I'm using is I'm building these systems where the machine is capable of going into a certain space, but then, in a way, like Francis Bacon works with oil paint, and here's another quote, with oil paint being so fluid, the image is changing all the time while you're working. One thing either builds on another or destroys the other. It's really a continuous fight between accident and criticism. So what he says is, when you work with any kind of material, the material has its own behavior, its own way of shaping things, and it's not under your full control. Even if you're a painter and you know what you do, the paint makes up its own shapes. And some of them at some point are just in the right configuration, and you say, yes, this is what I was hoping for to get. And so when I'm working with these models, I feel exactly the same way. So I look at thousands of hundreds of variations, and some of them speak to me and others don't. But only when the model shows it to me, I can see it. So I know it when I see it. And then the point is, you are trying to find make accidents happen, but in a controlled fashion. So because what I call accident may give you some mark that seems to be more real, truer to the image than another one. But it's only your critical sense that can select it. So yes, so you build systems that are able to create beautiful accidents, but in the end, you are still the person who has to kind of pick them out of all the possibilities. So I call this technique of working with neural networks neurography, because what you do when you train a model, you build latent spaces, and that is kind of the internal abstract representation how models understand or get an understanding of the training data and the way you trained it. And then what you can do is you kind of navigate inside those spaces. And somebody closed my folder, so let me see, is it here? So there was the video, so I explained it. So now this video that you can see would kind of resemble a flight through latent space, where the model has kind of learned the visual qualities of my training set and then creates new abstract forms. And the interesting thing is that this space is continuous and it's able to create these abstract type of shapes, which in the end looks something like this, for example, or this. And you could say, yeah, maybe a human could have done this, and there is some interesting composition happening. And yeah, so I'm looking at these things and then say, oh yeah, this looks like some floating island to me and has some interesting texture going on, so I might pick it. The interesting thing about abstract images is that, again, Francis Bacon had something to say about that, because he says, I think it can convey a very watered down lyrical some very watered down lyrical feelings, because I think any shapes can. But I don't think it can really convey feeling in the grand sense. Can you find it? Oh,
yeah, for sure.
Because somebody must have posted it. Here we go. Yeah. Okay. Cool. Thank you.
There you go, man.
Thanks.
You're welcome.
Okay. So I can quickly show it to you. Oh, sorry. So. Here we go. So yeah, this is kind of this flight through latent space, and this is kind of a very early one. This piece is probably almost 2.5 years old, so the resolution is very, very low. But you can see there are these shapes recognizable, because in the end, the models have been trained on real-world data, and they kind of understand something about them, and then we kind of look at them and also think we recognize something in it. But yeah, so creating abstract images is interesting, but I kind of was trying to get more to actual content and creating these underlying content myself. And there are certain topics and things that we as humans are very interested in, and that's usually other humans. So I'm working, as you saw before, with the whole human shape, or the other thing is I work a lot with faces and portraits. Because a portrait is kind of like a face can tell so many things, and we can read so many things. Again, a quote by Francis Bacon, my ideal would be really to just pick up a handful of paint and throw it at the canvas and hope that the portrait was there. And so in that sense, I would say I'm definitely in the same spirit, only that I build machines that are in a way able to do that by kind of throwing pixels at the screen and actually creating portraits. So I call this kind of neural face. And the way I do this is by training models on biometric face markers. And biometric face markers look something like this. So you can feed in video data or photos, and then they extract you these 64 points, which are delineating the kind of like important parts of your face. And then I can use GANs, like we heard about before, and I can train them on like learning how to transform something like this simple representation into something that looks more painterly or photographic, photorealistic. So one example is this, where I trained data on the British Library collection, which is all these kind of engravings and things. So, and what you can see is these faces on the left side are randomly generated by interpolating, extrapolating through, I don't know, 100,000 of faces I harvested. And in the end, the model only saw these engravings and it started reproducing something that looks like it. Again, this is a very early work. And of course, I try to improve my methods over time. And because I really like I love textures, and right now this low resolution stuff is nice and gives you content, but I want to kind of, one of my battles of the past, let's say 2 years, was getting up the resolution and getting detail into it, because there's something about texture that goes immediately into our brains that like pure content cannot do. Oh, sorry, there's another video, yes, video 4. So, so one thing that I improved over time was getting the speed up as well. So this is a video which takes me and my face markers, and then I trained it on old masters' paintings, and you can see kind of like how the model is able or interpolates through this space and creates a new face. And it gives you like, and you can also see the limitations, because in some sense models can only kind of interpolate in a certain range of what they have seen before. So if they have never seen an open mouth, they will not know how teeth look and these things. But of course, is this interesting space where you can take them, if you take them out of the range they know about. And yes, now I'm able to produce an infinite amount of things that look like paintings of old masters, but of course, I mean, do we need that really? So for me, this is more like a benchmark to say, yes, the model is able to do that, but it's not really my aim. So let me show you the last video. What I prefer is building these feedback loops where I feed the output of the model back into the input and connect these neural networks together, and then they start making up their own content and misunderstand each other and go into these weird spaces. We don't want the other one. Okay, so back to the thing. So now with this, I'm able to produce, let's say, higher resolution stuff and weird. And so now I'm getting into the space where there's some texture happening and weird juxtapositions and new types of things coming out of it. And the next step, or the step that I'm currently on, is then like when I have a trained model, which is kind of this thing that is then able to produce something it has learned, I look into how I can kind of deliberately glitch it or introduce errors into it and make it kind of misclassify things. And so you could almost see, like in this case, for example, I take a model, and the first image on top is kind of what it regularly produces, but then I delete half of the weights it knows, half of the thing it has learned, and then I repeat that and repeat that. And you can see it still maintains something like of a weird memory of what it knew, and it reminds me a lot of these kind of when artists, there are artists that developed Alzheimer's, for example, and then how over years their capabilities reduced. So, and of course, the much more interesting space of what these models are able to produce is in these in-between spaces where they really kind of create something, well, I find very aesthetic. And so, yeah, I'm now experimenting a lot with these neural glitches because these models have this separation into superficial features, let's say decorative elements, textures, but also at the same time this semantic level where they kind of know, okay, this is this set of filters or weights is responsible to detect eyes or faces. And when I glitch them, they are able to create semantic errors in some sense. And that is kind of different to like the classic approach of glitching where you just like take a file format and just break it, because those glitches are usually more on the superficial surface level, and can never really create new content. So this is kind of where I'm currently at, trying to, and yes, it's often looks very kind of gruesome, but well, if I look at this, I mostly see interesting textures and light and dark areas, and of course, and yes, you can say it reminds you of Francis Bacon. Actually, if you put them next to each other, I don't really think it is. Maybe we have to readjust, or maybe, well, I hope, that I can still stand next to it and create my own type of style. But yeah, thank you so much, and sorry for the technical difficulties.
I think it's, yeah. So the microphone is working. And now we can move on to our second speaker. We have Coralie Vogelaar, who is a visual artist with a graphic design background and who is conducting systematic studies revealing mechanisms happening in our visual culture. She uses quantitative research methods such as image and emotion recognition software and eye tracking. And Coralie also has some work being exhibited in our exhibition. So there's a drawing bot that looks at the message board 4chan. So if you haven't made it to the exhibition yet, you should definitely drop by and see Coralie's work. And yes, I guess now she will talk about some of her other exciting pieces.
Yeah, and I also will talk a bit about
Okay. Very good. So we'll hear about a few things from Coralie once we're all set up.
Yeah, I will show, hi. I will show 2 projects, and one of them is from the IMPAKT. The IMPAKT I just finished yesterday, so I'm still figuring out what it exactly is. But I think I will be fine. Okay, what I want to focus upon is how we can use, or like how I use it, computer vision and AI to show something in a different way than what we used to. Because indeed, what Mario said, the brain is very lazy, and we often now use algorithms and AI to make things more simple or more understandable, and also it's very much copying what we already know. So the first project I'm going to show is about emotion recognition software, and this software is for me, when I play around with it and interact with it, it's very much simplifying my emotions. It's mainly saying, hey, you're happy, you're 30% sad. And for me, this is very simplified way. And also, I notice in my behavior, it's reacting on me the most when I smile or look surprised. So it's very much triggering the very boring behavior of me. So I wanted to turn it around, to use this computer technology to make emotions more complex, because that's also what algorithms should be able to do. I decided to work with an actress, Marina Miller-Dessau. She lives in Berlin, and she's very good with her face. So I, together with Marjolein Vogels, we are working together a lot. And she's a choreographer, so she yeah, she's very knowledgeable in how the body moves. And what we did, we trained her to move all the muscles individually. So the face has 43 muscles, and we trained her to move them separately. And also these are the muscles that the computer tracks. And Paul Ekman, he's from the, he did a research in the late 70s, and he mapped out these muscles, and it forms the basis for emotion recognition software. Actually, how the muscles, that's very thoroughly done, so I like that part. He also decided, or not only his decision, but the analyzation of the 6 basic emotions, that's also, that's the other part he did, and that I don't agree that much. But the muscles are very nicely mapped out. And yeah, a couple of projects came out from this. Oh, this is actually so this is Paul Ekman, and he made this system, the coding system. And every emotion is a couple of muscles. So if you have 43 muscles, the possibilities are almost limitless, because you can do 6 muscles together, for example. So yeah, then it's like you can have very many expressions. Yeah, so we trained with, sorry, I will firstly explain what you look at. This is one of the video pieces that came out of it. What we did, we did a recording of Marina reacting to what we were telling her. So we were telling, like, you're walking on the street, you see somebody that's you're scared of, and or we told her a joke, or we said something very sad, and she reacted on us very emotionally. And this was a 20-minute shot. And then in the evening, because I can now read Ekman, so I mapped out all the muscles she used, and then the day after, we did it on commandos. So she's doing the same as the day before, but then what the computer would see. So you see on the right kind of a computer version of Marina. And interesting, for example, is the computer is not trained to detect tears, for example. But for us, tears are very emotional. Like for us, tears are quite important. But also, I think this piece is showing us a new way of looking, because normally we wouldn't look at a face, we wouldn't pay attention to all these muscles. But actually, it's kind of beautiful what the face can do. So yeah, for me, this is showing me a new way to see the complexity of the face. Yeah, so this one piece, it's still at show in Amsterdam. You can still visit it this weekend. We also did a performance. Yeah, because of time, I wouldn't. Maybe I skipped this one, but what the sound direct with her facial movements. She also directed sound, and she's mixing up these robot movements and emotional movements together, and yeah, it's very like an emotional roller coaster you witness. And another video that came out of it was because I wanted to explore, yeah, more the complexity of the face even more. And what I did then is I let the computer print out random numbers for me, and that's also like a lot of deep learning algorithms work. They always start with a random number, or because randomness is a way to explore something. And what I did there, I instructed Marina these random numbers, and in that way, we kind of explored what the face can do. So it was very much, yeah, just seeing what can it do, and then instead of what does it mean, and then I let the computer analyze it again. So what kind of emotion is this? And sometimes the computer is actually pretty right, but often it's also like, oh, I didn't know that was sad, or yeah. So it's kind of an interaction between the computer and the face in a way. And I also like Marina. Her look is pretty like she has kind of an ageless look to her because she has gray hair, but she's very young. And she looks a bit like an avatar, I think. So she has a computer quality to her. Yeah, and this is played out randomly also, if you see it in the real. Yeah, this is how it was installed now in Amsterdam. To IMPAKT, I'm now showing a machine. It was working finally 10 minutes before the opening yesterday. So I'm happy about that. You can, so you can now see it working, luckily. What it does, it's very complex, so I hope I can explain it in a short amount of time. So it's a robot that is drawing or writing, and it's got its knowledge from 4chan, and what on 4chan they say about artificial intelligence. So I scraped all the alineas that's dealing with artificial intelligence, and that is the basis for the bot. And the AI is then creating sentences based on that database. And it's very simple deep learning algorithm. It's called Markov chain. I also use it with my students, very easy one. But I also like that it's not that sophisticated, because it's what it does. It's purely statistics. So it's after this word, then probably this word will come, and then this word. But what the result is these sentences are pretty. Sometimes they're pretty funny, or or sometimes they're philosophical or absurd. So I really like the sentences that come out of it. And then I was also interested with other rudimentary neural nets. So the neural nets that's not really functioning like it should be, but in a beginning stage, and that is with the handwriting algorithm. So, and then it's also often a bit off. And I like to, I really like to use this kind of algorithms that are not a exact copy, like it's a perfectly handwritten robot, but it's kind of, it's doing sometimes a weird choice, or it's because it's a mistake actually, or a glitch, but for me it's generating a new visual language. You can see it working. I quickly made this with my iPhone yesterday. It's when it's finished writing, and then it's rolling up the paper. And I really like the fact that I still am struggling with the machine. It seems like it's not doing all the time what I want, so I have a weird relationship with it now. It feels also like a entity, like, oh, what it is. So I'm still looking at it. Oh, what did I create it, or what does it do now? So it's kind of cool. But probably in 3 weeks I will know what it exactly is about. Now I can only say, this is what it does. Okay. Thank you.
Thank you so much, Coralie. So next up, we have Jaeger Kraft, who is an interdisciplinary artist currently living and working in Moscow, Vienna, and Berlin. He acquired his education in fine arts in Sweden, firstly, at the art school Gerlesborgsskolan, and continued at the Moscow Radchenka Art School, the Academy of Fine Arts in Vienna, and Central St. Martin's in London. And then also the New Normal postgraduate research program at Strelka. And there, I believe he also developed the Airkiss piece, which is currently also in the exhibition. So if you haven't made it there, that's another reason to go. And I see we're all technically ready. So yeah, welcome, Egor.
Thank you, Luba, and thank you, Mario and Coralie, for these brilliant presentations. Thank you, IMPAKT team, for having me here. So, in this talk, I would like to focus on the project that is to do with the topic that we're discussing here, a machine learning topic and AI. And before I start showing you pictures and talking about the project, I would like to expand a little bit upon the research that has made, and two really important stories for me that actually brought me to starting this research. And one of the stories is a story about the Voynich manuscript, which is a well-known 15th century book written in supposedly unrecognized language and weirdly illustrated also, with some strange naked female bodies and unrecognizable strange kind of plants. And for centuries, this book has been a subject to speculation and conspiracy theories. And there were, versions and interpretations where people thought that this was the book that was written by aliens, or it was a hoax that has never existed, that is supposedly a book from 15th century, but it actually is just a recently created hoax. And the interesting part is that when this ancient mystery made its way to the artificial intelligence community, and it happened beginning of this year, when computing scientist in University of Alberta called Greg Kondrack, who is renowned for his work in natural language processing, together with his graduate student, set out to use computers for decoding the human language using the Voynich manuscript as a case study. And just a few words on neural language processing is a subject of artificial intelligence defined as a helping computers understand human language. And what's interesting is that, so the first thing that they tried to do when they started working with Voynich manuscript is they tried to, obviously tried to figure out what was the language that it was written in. And according to alleged version of historians, it was written in Arabic, although the algorithm that they have created and the data set that used 400 different languages from Universal Declaration of Human Rights to systematically identify the language of the Voynich manuscript has actually proposed that it was not written in Arabic, but it was actually written in Hebrew. And about 80% of the words have been found in the Hebrew dictionary from the Voynich manuscript. Although a complete translation still remains somewhat unwieldy because it requires the expertise from from people working with Hebrew languages. But what's interesting is that they managed to translate the very first sentence of this Voynich manuscript, and the text goes as follows. She made recommendations to the priests, men of the house, and me and people. And it's a kind of strange sentence to start manuscript with, but it definitely makes sense. But I think what's more interesting, and especially for me particularly in this story, is that once there were articles came out with the story that I've just told you, there was a lot of contradiction and a lot of conversation in the community, and academics from the and scholars from the with the historical backgrounds, they have claimed that there's no way it can be truth. That there's no way it can be written in Hebrew. That it's definitely written in Arabic, and this first sentence does not make any sense, and it's not just not possible that it is what algorithm supposes that it is. And I think that this is a very interesting kind of fracture in which we now are in a situation where we have a certain technology that is able to produce a certain knowledge or analyze a certain knowledge in a way in which a human brain is not capable of, right? Is not capable of having this information of this many languages at the same time, probably. And it's also interesting then to speculate and to think about if we can potentially be using such technology for trying to for bringing in details into some certain historical events, and we also know that there's usually a lot of different histories of certain historical events, and in this way we can potentially speculate of AI and machine learning as a kind of means of unbiased agency that is able to bring in some kind of the perspective of a completely different subjectivity that is not trying to bias a certain knowledge in a certain way. But it also, I think, brings a lot of ethical questions as to can we actually think of, like, can we actually entrust algorithms such analysis, and can we actually take it as serious, and can we actually rewrite our history based on this analysis? If we imagine a situation in which we create a data set of a huge historical drama, such as World War II, for example, and try to bring in as many details in there as we can, and then ask an algorithm for to deliver us a certain common denominator scenario, can we actually take it for serious or not? And the other story that I wanted to talk about quickly is it's a short thing, and it's a story about the very famous Laocoon sculpture, and the arm of the sculpture. You know, it is. I think it's quite well known that the sculpture exists in two versions, or at least we have these two different. We know these two different pictures of the sculpture, and we see that the arm on the left top corner, the arm is outstretched in the version on the left, and it's bent in the version in this image on the right. And so the story about it is that in the 15th century, a Pope's architect held a contest in which he asked local artists to complete the arm because it was missing at the sculpture, and he asked Raphael to be the judge. And Raphael, there was a contest, and Raphael chose one of his students named Jacopo Sansovino to complete the arm in line with Raphael's own beliefs what it should be. For some reason, it has never been attached, and instead there was a different arm attached to it, created by Michelangelo's former assistant. And Michelangelo had his own idea of what the arm was, and he thought that the arm was actually bent. But his assistant made an outstretched arm. And in 1905, the Austro-Czech archaeologist Ludwig Pollock discovered the original missing arm in Rome, and the arm that he discovered was this arm that you see on the picture on the right. So in fact, it was a bent arm, as Michelangelo had suspected. So this means that basically the position of the arm had been that had been originally suspected that the arm that was attached to the sculpture was basically incorrect for 100 years. Okay, and what I want to talk about is the work that I've been doing for about a year or a year and a half now, together with my collaborator Artem Konevsky, who is a machine learning programmer and developer. And so what we're doing with the project is we are looking for ways to use machine learning for speculatively recreating missing fragments in the sculptures of classical antiquity. And what we started with was, so the first thing that we wanted to do is we wanted to focus on the portrait, because it's easy to work with the portraits. And there's a lot of already ready for use algorithms created for this that we could utilize. And so the first thing that we did is we created a data set. I'm just going to play it. This is just to show you that the amount of data that we have created for creating this data set for the analysis. And so in order to create this data, we had to have 3D models of the sculptures, and we found a lot of models online. We requested a lot of models from Metropolitan Museum in New York and British Museum in London. And so once we first fed all of this imagery into the algorithm, the first thing that we have received was this type of result. And there was quite a popular GAN network. Mario was talking about GAN networks just now. Probably used very similar GAN networks. And I also like the references, him referencing a lot about Francis Bacon's work, because I do also think that this has also something to do aesthetically with Francis Bacon's paintings. So I just also wanted to show you a video of this being processed. So once we have received these results, we were quite interested about them, but we also were interested in what is that we can do in order to try and be a little bit more precise. We did not really aim to make a project that would be some kind of meta-archaeological attempt to actually restore what was there, but of course we were interested in these artistic interpretations, or what does AI as a different type of subjectivity can think of what antique portrait looks like. And then we created a different network which was customly made that has delivered different type of results. And this video here is one of its side products. So each frame in this video is basically its interpretation of what antique portrait looks like, and each frame of this video is potentially a new sculpture. But since we wanted to work with 3D, we had to develop our own. We had to find what would be a technical solution to do this, because when data set consisting of images is already a huge amount of data and requires a lot of computing power to process, and if it was a data set consisting of 3D objects, this would be such an enormously heavy data set that we would need a GPU that would be maybe the size of this building to process it. So what we did is we exported these images into the depth maps. So depth maps are the images that there are sort of like X-rays of 3D models in which you can easily translate into 3D model afterwards. So it's like a map of what 3D models looks like from a certain view, where where the pixel that is closest to the camera or to the viewer is brighter, and the one that is further is darker. And this has allowed us to work on it in 3D, actually. So we use the same GAN networks that Mario was talking about, but we were able to convert these results back into 3D models afterwards. And now I want to show you a few pictures that show the works that we have produced. And this has been exhibited in Hermitage in St. Petersburg, my hometown. A city which has a huge collection of antiquity. And there we were showing these two pieces, one of which was this portrait that you can see on the left, a couple of videos, and a speculative reconstruction of a fragment from Parthenon Frieze. And so this is a portrait here. So what we did is we used an existing portrait that is in collection of Metropolitan Museum in New York. It's a portrait of Lucius Verus, and we created a replica of that in marble, but in different scale that you can see on this. The sculpture here that you can see, it consists of two pieces, and one of them is produced in marble, and the other one is produced in polyamide, 3D printed in polyamide. So the one that is 3D printed in polyamide is exactly what we have received from the algorithm, thinking of what it should actually look like. And it looks like quite okay here, I think, but if we look at the picture here, then we can see that the algorithm has completely, it went pretty accurate here, but it has completely ignored the beard. You see it kind of shaved the cheek of this emperor, because he probably thought that the beard was a noise or a crack or something. And this one here is a picture of the Parthenon Frieze that we tried to reconstruct, and you probably have seen the Parthenon Frieze in British Museum, and the way it has exhibited there is that all the fragments that are missing in the frieze, which is about, I think, 40% of fragments, they are not present. So if you have a fragment that doesn't have something in the middle, you would have a piece on the left and an empty space and a piece on the right. And this was exactly the case here with this bit, and so you can maybe see, it's not maybe very clearly seen here on this picture, but you can see there's two lines. The one on the left is more vertical, and the one on the right is more curved. And basically, what's sitting in between these two lines is what the algorithm delivered to us as its own interpretation of what it should be, of what it was. And what's interesting is we can see better here that on the left you can see that there's a horse rider, and the leg of a horse rider is quite accurately positioned and very proportional to the original fragment. But the horse probably there were two horses, most likely there were two horses in this fragment, but instead we can see one really strange horse with 6 legs, and this horse hair going up. So a really strange creature. I probably must also add that we did not bring any adjustments, so we tried to use the data as pure as we have received it from the machine, and then we produced a 3D model that was later CNC milled in marble. So this has been produced in marble in original size of Parthenon Frieze blocks. All right, so this is a video where we can see some other fragments being restored. And a few more pictures on, this was recently shown at ZKM in Karlsruhe, where I was showing another two portraits, also from the Hellenistic era, some videos and a sculpture. And this is a fragment. On the left you can see a frieze that was show, and so you can see this crack, and basically this crack is what's on the right of this crack is what has actually existed. It's a fragment of a smaller Parthenon Frieze shown in Berlin, and what's on the left is what AI thinks there should be. This is another frieze which was entirely generated. We were trying to work in a different way, with not just trying to actually reconstruct the existing fragments, but also produce new fragments. And it was interesting, to work with this as we have the data set was large enough for the machine, if we let it train long enough, that it could produce a very clear and very accurate results, which would be portraits of friezes of antiquity that has actually never existed. And this was one of them. And a few more pictures of recent portraits. So, thank you so much.
Thank you so much, Egor. So finally, we have Nicolas Maigret, who together with Maria Roskovska founded disnovation.org, which is a working group aiming to disrupt, pervert, and complexify the accounts of technological innovation. The group develops situations of disturbance, speculation, and debate, challenging the ideology of innovation and stimulating the dissemination of alternative narratives. Nicolas Maigret has exhibited at a variety of places, including Transmediale, Palais de Tokyo, Polytechnic Museum in Russia, and beyond. So now, once Nicolas has poured his water in preparation for his exciting talk, you should be ready to hear it.
Thank you, Luba. So I'm Nicolas, I'm part of the Disnovation Collective, and I'm going to talk about our works and somehow how it connects with the subject of black boxes, automation, bots, and AI. So the Disnovation Collective investigates the societal effects of technological innovation and somehow their potential empowering forms of misuses or appropriations. So it revolves around the fields of technocritics and hacking. We do different things. So one aspect, which is quite a big aspect, is curation. So stuff that we show in festivals, but also debates, symposiums. There we investigate the rhetoric of technological innovation and the growing effect of this dominant ideology on society. We also do research, editing, and books, like the Parrot book that we edited with Axioma, and it investigates the practices of so-called piracy of necessity in different parts of the world with interviews and documentation. We also do lots of site-specific events, performances, installation. Like here with the opening of the Museum of Failures in Basel. It was a groundbreaking ceremony, sort of a symbolic event. And finally, the part I'm gonna speak more about today is net-based project and experiments, where we fabricate daemons, background processes that are monitoring large-scale activity on the internet. And with that, we try to reveal the black boxes or the workings of the infrastructure we use every day. So I'm gonna play a quick sample of the pirate cinema. So you will see that this project connects pretty well and introduces pretty well to the predictive outbot that I will present in a second in the way that it somehow gives a bird eyes view or a top view on a larger phenomenon. So I would like to contextualize a little bit predictive outbot by starting the talk with a discussion on hyperconnectivity. So I will frame a little bit hyperconnectivity and the predictability of our online behaviors. Yeah, so since about 10 years, smartphone took a large part in our daily life and daily practices, and it has a lot of effects on us. The online info streams have largely replaced mainstream media. We consume mostly through social media. And online news and communication tends to monopolize a lot of our attention and has a growing influence on the types of concerns, the things we are concerned with on a daily basis, and our priorities in a way. So we name this effect either filter bubble, media echo chamber. Some call it post-truth from other angles. But this is exactly what has been somehow used and abused by the influence industry. And to some extent, this influence of social media tends toward a form of uniformization, not only on the types of concerns, the things we are concerned with on a daily basis, but also perhaps of our imagination and creativity. So this potential uniformization of our imaginaries and concerns also creates a higher chance or a higher potential for predictability. So we started noticing this kind of patterns, not only in the larger cultural and media sphere, but also in the art world and in the art practices. We started to spot and to identify around us many examples, recurrent examples of similar topics, similar ideas, and even similar ways of realizing artworks or answering to issues. And at some point, we came with this question: do we really need artists to simply follow the trends or to simply react to trends with such, some sort of reflex? We could call it reflex art in a way, if you look at it on a meta scale, right? So it was sort of a a joke, an absurd take on the system, but also something pretty serious in what it could lead to and the after effects of it. So I will present it a little bit in a clearer way. So that's where the project actually started. So what if we started to automatize the mainstream creativity patterns toward the absurd? So creating sort of a short circuit in the relation we have with media, social media, and the consumption of keywords, trends, and buzzwords. And can it allow something else to emerge at some point? So I will play a short introduction clip to the project.
Predictive Art Bot is an algorithm that turns the latest media headlines into artistic concepts. In the age of hyperconnectivity, the perverse implications of media echo chambers are becoming more and more obvious. Groups of similar behaviors are being partitioned in filter bubbles, while the few massively reposted topics tend to monopolize most of the available attention. Such insular echo chambers strongly affect ways of thinking, resulting in increasingly homogeneous imaginaries within groups of like-minded people. Predictive Art Bot caricatures the predictability of media-influenced artistic concepts by automating and skirting the human creative process. But beyond mere automation, it aims to stimulate unbridled, counterintuitive, and even disconcerting associations of ideas. To do so, it continually monitors emerging trends among the most influential news sources in fields as heterogeneous as politics, environment, innovation, culture, activism, or health. On this basis, it identifies and combines keywords to generate concepts of artworks in a fully automated way, ranging from unreasonable to prophetic through absurd. Each prediction becomes a thought experiment waiting to be incubated, misused, or appropriated by a human host.
So this is where we will connect pretty much with the field of AI and machine learning, maybe not from such a technical point, but more from general observations. So we got some inspiration from the field of machine learning and more specifically from the idea of navigating a latent space. So Mario did introduce a little bit to that. Somehow what you can see here is the latent space of 50,000 fonts or typography that has been analyzed, and what you can see is the correlation, the proximity, and the vectorial transformation from one font to the other. But on the other hand, what is very interesting is that this sort of processes also reveals unoccupied spaces. So in a way, we could represent it like with this Tisney map, where you will have the clouds of occupied spaces by different corpus of information of your database, but it also reveals by the blank spaces what is not occupied, what is not often occupied. And from a symbolic or from a more theoretical approach, we were very interested in that for the concepts of the bot. So somehow, how could we, by using a bot, an automated system, by using some very basic, low-level machine learning system, create something that both caricatures the process of ideation or idea creation, but also somehow proposes something a bit more alien than human idea generation. So the way it works is pretty dumb. We did subscribe the bot to about hundreds of news sources. The bot is reading the headlines, and it identifies keywords that he believes are important in this sentence. It collects the keywords, and then using a library called Tracery, it creates this kind of generative poetry. So you have a couple of, you have a long list of potential recipes to assemble those keywords, and it will come out with this kind of proto-conceptual forms.
Work with Predictive Art Bot. Start today.
So from this point, we got very interested in how we could somehow force the hand of chance and make the concept of the bot real, to force the implementation of those concepts in the real space. So what you can see here is one of the early shape that the bot took. It's a form of a concept factory. And what you can see on the top is the result or the representation of a call or commission for artist interpretation of the concepts. So we really tried to encourage the real-life effects of the bot by commissioning actual artists to interpret them. But this is where it got interesting, because at the same time we were experimenting with that, we started to notice, so this is the document for the commissioning of the works. At the same time we were studying that, we started to notice that people were actually working for the bot without we even asked for that. So on many layers, so I will just mention 5 of those examples. So first of all, people were curating the concepts for the bot. So basically, by just watching at the site, the bot, and deciding to share some of the concepts, the followers were already working for this entity. The other way was a lot of people were starting to document some of the concepts that we are not storing. We are not making any archive of it. So actually people were starting to do the archiving process. Then by the simple fact of watching the Twitter feed and the simple fact of interacting with it, liking, reposting and so on, people were interacting with the ranking and how much you are likely to see this concept in your feed. Then we also had interesting reactions, people just reacting to the concepts by producing a poem or art pieces. And one that I think is among the most interesting is lots of people started to spot or to identify when the concepts of the bot were reminiscent of existing things. So you can see a funny one here, which is the same day as Elon Musk sent his Tesla car into space. The bot came with a very similar sort of concept. And the last one is finally people that propose to realize the project by themselves. So as a conclusion, one point is that the concept that this machine or system is producing can be alien, and somehow they can be challenging or inspiring. But what seems even more interesting to me is that this whole project acts as a mirror or as a challenging entity to our own creative reflexes or automatism. And perhaps it's an interesting contribution to the debate about AI that we will have in a minute. So that's it for now, and thank you for your attention.
Thank you so much, Nicolas. So I'd like to welcome Egor, Mario, and Coralie back on stage for a short Q&A. So please do all come back up. So I'm going to ask the panel maybe 1 or 2 questions, and then I'd like to hear from you, the audience. So get thinking what you would like us to talk about. So Nicolas, I like how you kind of wrapped out our panel with your example of the predictive art bot, which to me has always been kind of an example of how you can look at automating some of the artistic process. And I know, Mario, you have always thought about, too, with kind of building systems that look at your thousands of generated images and kind of figure out which ones cater the most to your own taste. So I like to see how you've kind of all thought about using this technology in your own practice. And as artists of today and the future, how do you think these technologies will affect and shape your practice and the role artists play? Coralie, yeah, you go first. And I think you even might have a microphone. I don't know if this works, but try it.
Hello? No? Okay, thanks. Yeah, for me, but yeah, I can only answer this from a personal perspective, of course. For me, I see AI and all other computer technology also like mathematics or statistics, and I also like, for example, in other works that I see, Kiersmaker is a great choreographer working with mathematics. So for me it's very, it's not, it's a kind of similar way of working to set up a structure in which things can happen. So you design the structure with the help of mathematics, and in this case with AI, and then it can flow in the structure you build. Is that an answer to your question? Kind of, yeah. So, yeah, it's a nice tactic to let stuff happen, but you control it still.
Should I go? I also dare not to make any kind of predictions how it will change, but actually, well, I think there's a common topic, and I also, especially in the last talk, and that is my frustration, that in some sense it feels like everybody's working from some kind of recipe, and like, yes, so yeah, it looks like people think they have figured out art, and then they make this concept, and so that's where my hope is that, because I think we are all very limited in our imagination, and yeah, so I'm kind of frustrated because everything I see is boring me already, because it seems even like the most kind of like controversial stuff is just controversial because it gives you attention. Maybe there is some true, okay, probably most people have a true motivation behind things, but for me, it all feels stale. So that's where I have hope in the machines, that they are able to go to these places which are kind of the white spots on the map, and show us something that is, our lazy brains are not kind of want to go, or, because yes, I feel like humans go for this shortest route in our thinking, and the machine is able to show us something else, and hopefully then trigger actually some of the stuff that came out of the predictive art, but actually might be good, right? And but you have to see it in order to make it. So, and that's where I have my hope in the machines. Like, show me something, and I make some new, and trigger some new ideas in me.
Yeah. Okay. Yeah, and even even on a larger scale than just the art field, what is quite interesting in what machine learning is producing, or neural network are producing. I mean, for sure, you can use a lot of it for doing illustrations, for doing generative artworks, and so on and so on. But also, from a more cultural perspective or knowledge perspective, it's interesting in the way it reveals, or it acts as a mirror by showing how, as a society, we build cultural heritage, or we build archiving, or we build history making. And somehow those systems are materializing and allowing us to look at that, which is a sort of things which is quite hard to look at without those tools. So, for instance, I know that you commissioned a work by Constant Dullard that tries to see at what it means to be European, right? And that's a kind of a good example of that. And I think, even from a non-artistic perspective, where those systems can let you see biases, and also the kind of shape that by default cultural accumulation produces.
what I think very interesting is I also like very much that you referred to Walter Benjamin's text in the beginning of your talk, Mario, where this very famous and very important for us media artists here text, The Work of Art in the Age of Mechanical Reproduction. And I think there was this Medium, big post in the Medium that was called something like The Work of Art in the Age of Artificial Production, The Work of Art in the Age of Algorithmic Reproduction, I think it was called. Yeah, this was yours version. And I think this is still a lot to be analyzed yet, really, and a lot to be. I think we don't really know how much will it change and what it will result into. But what's interesting is to see that in a way we have learned with like GANs, for example, with GAN applications of AI, we have managed to somehow automate modernism, I think. So we're like, as artists, we have already passed by modernism a long time ago. But now we have even already discovered a way to automate it completely and produce modernism, or like let it be produced on its own, on one hand. On the other hand, it's very much to do with this. What machine delivers is very much to do with common denominator kind of thing, that we always can feed a huge amount of data and get something that is in between all of this data, that is a common denominator that responds, which is maybe a very good analysis of what is it that we actually have, this huge amount of information that we have produced. But on the other hand, what I think is interesting is that it's also a lot to do with a different subjectivity type of thing, which I am particularly very much interested in, is that if we have learned, if we have managed to find ways for silicon molecules to operate in a similar way as our protein cells do, and simulate the ways we think and teach these machines to think these ways, then we can probably think of and talk of AI as a different form of subjectivity that has yet to be understood. And I think I personally think that it's more interesting not to teach it to do things that we have already learned to do, but rather to find out about what it is contains that we don't know yet, and find a way to discover that. I mean, I'm being very vague right now, but it's a very vague idea anyway.
Indeed. Yes. So I'm just being very conscious of time, and I think we have time just for one question from the audience. So if you do have a question, raise your hand, and we might be able to answer it. Nobody dares. We've we will schedule away. Yeah, so I guess in that case we will wrap up at this point. And yeah, so the next thing we have in the program is actually still continuing with this theme of automation, but it's looking more at film. And at 3 p.m. in Studio 3, did you say? Yes, in Studio 3, there will be some films that tackle this topic more from the perspective of the filmmaker. And I hope that our artists will be around kind of the festival for at least the rest of today or tomorrow. So if you do realize you have a question, you can ask them in person in those surroundings. Okay, thank you.